Okay, so even and odd functions, we kind of discussed this already in grade 12. Even functions is a function whose graph is symmetrical. Symmetrical with respect to the y-axis. So I'll draw some examples. A parabola. And the parabola doesn't have to be at 0, 0. It could be like this, right? Or upside down. The greatest trig one would be, what's an even function that's a trig function? A cosine. You see? Okay, so I'm going to erase this one and do another one. Of absolute value would be 1 as well. Yeah? Okay, so moving left or right produces the same function value. So I'll just prove to you with a different color pen. If I go right, I don't know, say this much, do you see it's the same as going left, the same amount, you get the same height, right? Like here, if I go the same distance here, I get the same height. Do you see what I'm saying there? Okay. So now if we're talking about area, which we're talking about right now in calculus, what do you think is neat about an even function? It's the same area, yeah. Do you see? If I shade from here to A, do you see this area? If this is an even function, it would be the same area going this way, right? So if the function y equals f of x is even and thus symmetrical over the y-axis, then going from negative a to a of an even function would be the same thing as going from 0 to a, finding the area and doing what to it? Multiplying it by 2, yes. Doubling it. I'll repeat. Sorry, so here's my 0. Do you see going from 0 to a and finding that area right here? That would be the same thing as doubling this and getting that side. You see it's symmetrical, so it would work. Okay, so odd functions, a function whose graph is symmetrical with respect to the origin. This means that the reflection over the x-axis is the same as a reflection over the y-axis. Remember, this was our little thing when we learned it in pre-cal. A reflection over the x-axis was the same as a reflection over the y-axis. An odd function represents two reflections. I just said that. A reflection over the x-axis and a reflection over the y-axis as compared to the original function. So that means f of x is the same as negative f of negative x. Okay, so examples would be a cubic function, which looks like this. Remember, that's what a cubic function looks like? Anybody remember a nice trig one that's sine? Yeah, sine is odd. You see, this would be the same as over here, and that would be the same as over here. Because if I do two reflections, so think about this for a second. If I take this point, reflect it over, that would be over here, and then reflect it over here, do you see it would be that part right there? Two reflections. This reflects here, this reflects down. And then, I don't know, I can just make something up like a windmill, something like that. Mind you, I should put it in a different quadrant because you think it has to be 1 and 3. It could be like this, like that, and that, and that.
Or even just y equals negative x.
Or y equals negative x, sure. All right. So the thing about the areas of an odd function, so if the function y equals f of x is an odd, thus symmetrical around about the origin, then what do we know about the areas? Look at the areas here. What do you think? Yeah, it equals 0. Isn't that kind of cool, hey? Okay, so this is the kind of questions they give you. This is pretty straightforward, multiple choice. Easy to do. If the integral from 2 to 7 of f of x is 12, and the integral from 5 to 7 of f of x is minus 4, and f of x is an even function, I forgot to mention that, find the integral from -5 to -2 of f of x, and those are your choices. Okay. So, what do we know about even functions again? Yeah, so the area from -5 to -2 would be the same thing as from 2 to 5 of f of x, yeah? I should have a dx in there. Yes? So? Can you calculate it? So we have to build that here. Does everybody see that? We have to build that. So does everybody see? Because 2 is on the bottom, I want 2 to stay there. So 2 to 7 of f of x dx, yes? Yes, so I'm not going to add these two together because the 7's have to match, right? So this is going to be the integral from 7 to 5. And in order to do that, I'm going to subtract it, right? Actually, I'm going to add it right now, and then I'm going to switch the signs of this to use it. That's the easiest way to understand it, right? Does everybody understand that this is the same thing as this right now, the way I have it written? Okay, so what's this area equal to? 12. And what's this area? Now, if I compare this area to this, it's not -4 now because I switched it. So what is it going to be? It's going to be 4. So it's going to be +4, which gives me 16. So that's my answer right there, 16. Everybody get how I got that? No. Because an even function would be the same area as the positive. Like for instance, an even function is something like this, right? Right? So if I'm going from 2 to 5, that would be the same area as going from -2 to -5 this way. Do you see that cover would be the same coverage there? Make sense to you? Okay, so let's go here. Given the graph of an odd function, which statement must be true? So I'll give you a second to do that. Okay, so because this is odd, remember this area would be the same as this area, right? So they're saying from A to 0 would be the same thing as 0 to A. Sorry, 0 to B. So that's not right. Does everybody see that? Okay. So now from A to B, that would equal 0. That's true, right? Because this would be negative, the same area as this, right? So that would be true. And then going from A to 0 would be the same thing as -0 to B. Is that true? Yep. So then my answer would be 2 and 3. Yeah. Okay, here's another AP question. If r of x is an even function and s of x is an odd function where yada yada is that and yada yada is that, find the value of -a to a of 2s of x minus r of x plus 3.
Can we just plug in for s of x the value of the integral of s of x from negative a to a?
So remember, r of x is the even function, so what do we know about that? Yeah, so let's go back to r of x. What do we know about this one then if this is even? Yeah, same area. So if it's going from -a to a of r of x dx, what would that equal? Yeah, 2 of that, right? So it would be 10. Does everybody see that part? Do you agree with that? Okay, so now if we take this, if we take this, and that's an odd function, right? So what would going from -a to a of s of x equal then? Right. There we see that if the collection of area from 0 to a would be -3, then from -a to 0, do you see that what that would be? Okay, then we have the 3. You have to know the little property of a constant, right? Yes? Okay, so we're going to plug her in. So the integral from -a to a, this would be 2s of x minus the integral. So this is 2 of that, right? I'm just separating them, just so you know. R of x plus the integral from -a to a of 3. These all have d of x, by the way. Okay, so what did we say the s of x is? That would be 2 times 0 minus, what did we say r of x was? 10, yes? Plus, what do we do here with a constant? It's what? 3 times this minus that, right? So what's this minus that? A minus minus A? Not, that would be 2A. So this is going to be minus 10 plus 6A. Okay, and now for my last one. See, I told you I could do this. Okay, if -k to k of f of x equals 2 of 0 to k, ooh, what does that mean when they state this? It's a what function? Even function. So you got to look for an even function here. There's only one there. Yeah? C. Thank you.